So, type a poll. Let's see. So, it says, have you, so I'm typing it up right now. Have you watched the recorded videos on section P.2? So it's a yes or no. Those are in the classroom. I'm going to bring that up and then share my screen to see, if you guys have seen that. But because for P.3, what I'm going over today, you need to have some understanding of P.2. So that's why I'm asking if you have done that, or at least, maybe even if you didn't read the recorded videos, if you've gone through P.2, because that will help things make sense. Missy, it says that you have raised your hand. Do you have a question?
Yes, I went through the P.2 in the textbook, but I've not watched the video.
Okay, that is fine. So at least you've
Okay.
gone through P.2, so you have some of that knowledge.
Okay, and the other question I have is, can everyone see each other? Because
no.
I look like crap. Like crap.
Your camera is not on, so right now
Okay.
nobody sees you. People just see me, so don't worry about that.
All right.
So I'm gonna share. So those of you, if you haven't seen those videos, if you've gone through P.2 in the textbook. Otherwise, if you click on the live sessions and instructor videos here on the left, then live session recordings, then week 1 recorded videos. So P.2, I've got 2 videos. I have simplifying exponential expressions, and this is the part that you're going to need a little bit of for today, and then simplifying radicals. So the simplifying radicals is not needed for this section. Okay, if you've only read the ebook, that is fine. I actually recommend I think it's actually better for most people to watch the video first and then do the ebook, because I think for most people watching it makes much more sense than if they're trying to read. So that might be a better route, is to watch the sections and then go back to the book. But you can do whatever works for you. So, okay. So we're about to split on whether people have watched those videos or not. I just want to make sure. I will go over the exponential expression stuff that you need very briefly when we need it. So, okay. So we're doing P.3 today, which is polynomials and special products. And so this shouldn't be too bad. It should be a pretty easy section for most people. I think P.2 is probably harder for most people than this one. So P.3 covers writing polynomials in standard form, adding, subtracting, and multiplying polynomials. We're not dividing them until we get to chapter 3. So we're only adding, subtracting, multiplying. Using special products to multiply polynomials, and then using polynomials to solve real-life problems. So I'm not going to be covering the real-life problems of polynomials today, because that's usually the real-life stuff. We usually see that in the discussions, and that's where you get to explore these concepts. So I'm just focusing on the skills that you need, the first 3 things here. So let's start with, what is a polynomial? Yes, you have a question.
Yeah, I'm sorry. Where do I type a question instead of raising my hand and stopping you from what you're doing?
There is, so when you're looking on your screen, there should be a purple button. It has like 2 little arrow things going to the left. If you click on there it will expand, and then there's a little chat bubble. And as long as you make sure you're on the chat bubble, that's where the chat should pop up for you to be able to type questions.
Okay. I've got a purple X.
Yeah, so when the purple X, that means it's expanded. So you should see like a little chat bubble, and then there's like a picture of like two people
Oh,
with a
okay,
number.
okay.
Yeah, so the chat bubble on the left, that first one, that's where you type in questions.
Okay, thank you. I'm sorry.
You're welcome.
Okay, go ahead.
All right.
All right.
So, going to what is a polynomial. So I did a little research because I've always I've always been interested in where these kinds of words come from. I have taken Latin, and so I look at polynomial, I'm like, well, nomial, that comes from the Latin word nomen, which means name. But I'm like, and I know that poly is Greek for many, but I'm like, many names, is that really what the word comes from? So I did some research, and I actually did find that that's literally how the word polynomial came about. So the word is found in English. This is actually the first instance of the word in English was in 1674. The person, Samuel Jake, I don't know, I'm assuming that's how you pronounce his name, but he said those knit together by both signs are called by some multinomials or polynomials, that is many named. So the word polynomial basically literally means many named. It's a combination of Greek and Latin. So he says that they're knit together by both signs. So what that means is that a polynomial is a combination of various terms, and there are signs in between them, plus and minus things. So there's stuff in between, and there are specific rules for something to be a polynomial. So for something to be a polynomial, all of the exponents have to be positive and whole numbers. So we have no fractions in our exponents, no negatives in our exponents, no decimals in the exponents. All exponents are positive and whole numbers. And your variable is never in the denominator. So if there are fractions, your variable has to be on the top, never the bottom. Your variable is never inside radicals. So you never have a variable inside a square root or a cubed root or anything like that. And your variables are never inside absolute values. So a polynomial is probably the most simplest type of expression that you'll see, because you don't have to deal with fractions and radicals and all these other symbols. So this is the definition of a polynomial. This picture comes directly from the textbook. So let's try to kind of learn what this means. So I'm going to kind of zoom in here. It says let A0, so that is read out loud as A naught. I'm going to actually, doesn't let me write when I'm zoomed in, but so that you understand what I'm saying and what that means. A0 is read as A naught, and it's not N-O-T, it's N-A-U-G-H-T, which is another word for zero. Nobody uses that word for zero anymore unless you're a mathematician. So if I say A naught, that's A0. And so A is just representing some number, basically, and then we're just numbering the numbers. So when we always start counting by 0. So those are numbers, and let n be a non-negative integer. So that's just a whole number that's positive. So a polynomial in x, and they're saying in x, that's our variable, is an expression. And an expression means that there's no equal signs. So we have no equal signs. So an expression of the form, and then this. So all this is saying is that we have a number in front, and then our exponents are counting down, because we have x to the n minus 1. It's just your exponents are counting from highest to lowest. So so this is positive and whole, and then expression, which means no equal sign. So an example would be like 5x to the 5th plus 3x to the 4th minus 2x cubed plus x squared minus 1x plus 5. It's just you have x's with variables, or with, I mean, not variables, with exponents, and you're just counting down from highest to lowest. That's the form of a polynomial. So the polynomial is of degree n, so the highest exponent is your degree. So that's what this is saying here. So the highest exponent is called the degree of the polynomial. So the example that I've given here would be degree 5. The leading coefficient is the number in front of that highest term. So our leading coefficient for this example that I've written is 5. That is the leading coefficient. And it's called the leading coefficient because it leads, it's in front. And then it says A naught is the constant term. That's just the number at the end that has no variable. That is called the constant term. So that's what that definition of a polynomial means. So essentially, if we go back to the top of my slide here, each term of a polynomial has the form ax to the k. It's just a number in front, an x, and then some exponent. And we have special names for the number of terms. So if you have one term, it's called a monomial. So mono means one. Two terms is a binomial. Bi means two. And then three terms is a trinomial. So tri means three. But we don't have any names for anything that's 4 or higher. We just call those polynomials. Most of the polynomials we look at are 1, 2, and 3 terms. So that's why those have special names. And then standard form of a polynomial is where you just write your exponents from highest to lowest, like I have in my example. So are there any questions on the definitions here, the wording, the terminology, and what this means? Yes, Missy.
I really hate to do this again. I had no algebra at all before this, and it's kind of a nightmare for me. I'm gonna utilize the suggestions that you gave me in your email, but I don't expect to do very well on this first.
I think you'll surprise yourself. If you focus on, like, okay, what do the words mean? Because a lot of algebra is understanding the terminology. Algebra really is another language. You're learning another language, and if you learn what the words mean and what you do with them, that should help you.
Okay.
And it is, if you're working with it and you're, if you need to go back to basics, I have videos from the sort of the classes lower than this one, MA104, and those can also help as well. That's why I'm spending time here on the vocabulary, because that really helps you understand what to do, is learning the words and what they mean.
All right, thank you.
You're welcome. And I see we do have somebody typing a question as well. Robert says he agrees with Missy. I know that a lot of you are in the same boat. That's why I have shared. So MA104 is like the course that's supposed to prepare you for college algebra, but not everybody has room to take that in their schedule if you don't have any rooms for electives and that sort of thing. So that's why I shared my videos for MA104. So that way, if you need to go back and to a little bit more of the basics, you can watch those videos. I would say it's completely fine to feel like you have no clue. I mean, you're in this class because you don't know this. That's exactly why you're here. You're learning this. This is new for everybody. So don't feel like you're supposed to have a complete understanding of everything here, because then you wouldn't need to take this class. So
Okay.
just treat this as new. This is new for everybody. So, listen, ask questions. If you need to do flashcards on vocabulary, that sort of thing, it will come to you with practice, and you will see that you are learning. It will start making sense. So you need to have a positive attitude. That's how you can be successful. So try to look on the positive and understand everybody's in the same boat here. That's why you're taking this class.
I am
So you are all learning.
completely positive on it. I love English and math has always evaded me. It just I could never get it, and I never got even half the algebra. I didn't get it, so I'm terrified of your class.
Don't be scared. A lot of people are like, they consider themselves English people because they're like, oh, I understand English. That's why I try to compare math to English and say it's like a language. You're learning vocabulary terms just like you have to do in English. If you consider the standard form of polynomials sort of like the grammar, when you're writing sentences, you have a certain order things go in. And
Right.
That's what math is. If you try to connect what you're learning back to English, like when you write an essay, you have the things in a certain order. It's like when you're solving a problem, think of it as writing an essay. Things have to be done in a certain order. Showing
Right.
your work is like, proving your point when you're writing an essay. So maybe if you try to think of all of this in terms of English, that could be more successful and kind of help your brain out and be like, oh, okay, I know what this means, or I kind of get the idea,
Okay.
So I don't know if that will work for everybody, but that's how I try to make the connection for those that are like, oh, okay. Try to make it, it's like another language. That's literally, you're learning the grammar, you're learning all of the same rules, vocabulary, spelling in a way is sort of like making sure everything's in the right order. That's what we're learning here.
Okay. Thank you.
Yeah, you're welcome. There are other questions or comments? A lot of people are in the same boat, 1990s or around there, for doing math, which is a long time, but that doesn't mean you can't do it.
1990, actually 1990.
Yeah, so a lot of you are all around the same point. So you guys should see about forming a study group. Maybe you guys can help each other out too.
Okay.
Great question, Letitia. Are we getting flashcards on the vocabulary and examples? So flashcards, I haven't created, I want to create flashcards for you guys. I have not done that yet because it's sort of time consuming, but I am going to, it is. If you open up the ebook, and I'm going to open this up, I'm going to show you how to create your own flashcards. I want to use the website Quizlet to create them, but I have not done that yet. I'm sure you guys take just the same different way than you guys because I'm an instructor. So I think it's even more clicks than. But I'm going to just click on the prerequisites here. And then this is where I last left off. So I'm going to click on chapter contents and then go to the start. I'm actually going to click here on polynomials because that's where we are right now. So if you want to create flashcards, let's say you can highlight this word and then you can say add flashcard. And so what you're going to want to do is say, okay, our key term here is polynomial. And then you can put what you want to remember. So we can say here, A series of terms added or subtracted. No variables in the denominator. All positive. Whole number. Help if I spell things correctly. Whole number exponents. And then you click save. Now, unfortunately, this only saves to me, so I can't share this with you guys. You're not going to see these flashcards, which is unfortunate, but you can create your own flashcards. And then to see your flashcards, it's this button over here. So when you create lots of them, then you would click here. So if I was in the book, I'd be here, and then I click here for flashcards. And then it looks like I have 3 flashcards. I must have created some already. So I can click, okay, I have a flashcard for real numbers. And then you click on it, all the numbers. That was my definition, all the numbers. So you can create your own flashcards to help you learn these things. So these, unfortunately, I wish I could share these. That's why I want to try to do a Quizlet. But I also have one for rational numbers. And then I tried to copy and paste. Copy and paste the math doesn't work. This is what you see. So you'll have to actually explain it in words because it doesn't do math. But that's how you can create your own flashcards to help you learn the vocabulary.
Okay.
And actually, while we're talking about this, while I don't have any Quizlet ones that I have created myself, there are flashcards other people have created through Quizlet. So this is something outside of Blackboard. And so I haven't created anything yet, but you can say, let's type in algebra into the search. And so these are flashcards other people have created. And so you can use somebody else's flashcards or study guides and to help you as well to study. So that would be something that you can do. There's lots of people have created lots of different flashcards. Like they have, like this one here talks about expressions, coefficients, these words that I've been talking about. So that's an outside resource you could use for flashcards. So other questions on learning definitions or anything before I move on? Okay. So let's move on to actually operations that you do with polynomials. So when you see the word operations, there are 4 operations. These are referring to addition, subtraction, multiplication, and division. So those are called mathematical operations. We are only going to do the first 3 because we won't hit division until we get to chapter 3. So we're going to be adding and subtracting and multiplying polynomials. So when we add or subtract polynomials, you are just combining like terms. So what that means is you have things that have the same variable with the same exponent on it, and then you add or subtract them by working with the numbers in front. If you have something with subtraction first, which means multiplying a -1 through the parentheses, and then you combine your like terms. And I will have examples all these. So you're applying, that's supposed to say multiple times. The distributive property multiple times. And then when we divide polynomials, you do long division, which you'll learn about in chapter 3. So we don't have to worry about that. That's chapter 3. So I'm going to start with addition and subtraction. And this is just by examples. So I have 2 examples here. The directions say simplify the following. So the word simplify means that you need to combine like terms and try to make as few things as possible. So when you see simplify terms, and you're just trying to make it as small as possible. So I have in parentheses 2x plus 1. So that is a binomial because that has two terms. There's one operation between two things on so there's one thing on either side, which is two things. Then I'm subtracting x squared minus three terms because there are two operations. So that is a trinomial. So when you're subtracting, this minus sign is really a negative 1 in this as 2x squared plus 1 plus a negative 1 times x squared minus 2x plus 1. So you can always write, if there's a negative, always think of that as adding a negative 1. Then we are going to multiply that negative 1 through the parentheses. So everything in the parentheses that follows gets multiplied by negative 1. So effectively, the signs are changing. So I have this 2x squared plus 1. Now, if there's no number in front of the parentheses and no plus or minus in front of the parentheses, you don't need those parentheses at all. So that's just 2x plus 1. Then I'm going to multiply negative 1 by everything in the parentheses that follow. So I have a negative 1 times x squared. If there's no number in front of the x squared, we treat that as a 1. So that is a negative 1 times 1, which is negative 1. So I'm going to write negative 1 and then x squared. So that the variable just kind of hangs out. Then I need to take negative 1 times negative 2. Apply the numbers. Negative 1 times negative 2 is a positive 2. So I write plus 2, and then my variable hangs out attached to it. Then I take negative 1 times 1. So negative 1 times 1 is negative 1, so I write negative 1. So I have distributed my negative through the parentheses, and now I need to combine like terms by adding things together that go together. So that means they need to have the same variables with the same exponents. So 2x squared and minus 1x squared, those are considered like terms because they both have an x, they both have the square on them. So those are like terms, which means I can combine those. So I follow the numbers. It says 2 minus 1 when I look at the numbers. 2 minus 1 is 1, so that is 1, and then my variable hangs out. So that's 1x squared. Now I want to write these from the thing with the x. I have 2x, and there's nothing else with an x, so that just stays there because there's nothing to combine it with. And then I have a, whoops, I meant to have a highlighter there, not a pen. I have plus 1 and minus 1, so you combine those together. 1 minus, if it gets to 0, I don't have to write it down at all. So now is 1x squared plus 2x. Because once I've added things together, I don't need to do it again. Are not like terms. They have different exponents on them, so they cannot be combined. So there are questions on this example. One common question I see is people say, how do I know when I'm done? Well, you know you're done when there's nothing else you can combine. So because these are not like terms, I can't combine them. There's nothing more I can do. I have to keep it that way. The second example on the right here, I have 4y squared minus 3 plus negative 7y squared plus 9. So both of these parentheses don't have any numbers in front of them. And if there's not a negative in front of them, then really you don't need the parentheses at all. So I can write this as 4y squared minus 3 plus negative 7y squared plus 9. So now that I've removed parentheses, now you want to combine your like terms. So we're going to look at the y squareds. Those match. They both have y, and they both have an exponent of 2 on the y. So those are like terms. So I add the numbers together. I have 4 plus negative 7, or 4 minus 7. So 4 minus 7 is negative 3. So that is negative 3, and then the y squared just hangs out attached to it. Next, I have a minus 3 and a plus 9. So those are like terms that I can combine together. Okay, Letitia, I will add these like terms. So let's combine the minus 3 plus 9. So that's a negative 3 plus 9, and that gives us plus 6. So Letitia asked, what do I mean by not needing the parentheses? So if you have parentheses, and right in front of the parentheses, there is either no number or symbol. So in front of the 4y squared minus 3, there's not a number and there's no symbol in there, then those parentheses are unnecessary. If you have a set of parentheses and there's a plus sign in front, but there's not a number, then those parentheses are also unnecessary. So the parentheses with the negative 7y squared plus 9 in front and it's a plus sign, we don't actually need those parentheses. And so I can just remove them completely. So that is what I did. And then we combine our like terms from there. And then our answer is negative 3y squared plus 6 because I can't combine something with a y and something without a y. They have to match. Other questions, or are there any questions? Yes, Missy.
Okay, so you came up with the, I'm sorry, the 9 minus negative 3 equals 6?
Yeah, so that's a negative 3 plus 9, which is the same thing as saying 9 minus 3. So 9 minus 3 gives me 6.
Right. So, how it's written, it just confuses me because why wouldn't we just say 9 minus 3 equals 6? And
Well, because I'm reading it in the order that it's written. And it's
okay.
not always going to be written with the highest and then the lowest following, because you can get these things given to you in any order. And so when we look at this, I read it always going, you want to read everything from left to right. So that's why it was negative 3 plus 9. You're always going to go left to right. Just like we read. When we read English, we go left to right.
Right. Okay. Well, thank you for our examples and how we can do that. That I was really worried about that, and I really needed to know about that and how to do that. So thank you.
You're welcome. Are there any other questions on what you see on the screen right now? Okay. Oh, that was just a no. Okay, so I'm going to move on now to multiplying polynomials. So when we multiply these things, there are multiple ways to do it. We can do it vertically, which the book does demonstrate, and I will not demonstrate that method because I think it's confusing. I don't think it's a good method. We could use the table method, which the book does not show, and which I will show because I think that is a much better way to multiply, because it's very similar to how we created times tables when you were in elementary school. There is the distributive property, and so I will demonstrate that. And then, actually, the book doesn't even really demonstrate that too much. And then we've got FOIL, which only works if we have binomials. So I'm going to go through the table method, the distributive property, and FOIL. And so you can choose pretty much whatever method works best for you. I am a firm believer of showing multiple ways to do a problem so that you can use the one that works best for the way your brain thinks. So if one of these methods doesn't work for you, but another one does, then use the other method. Because I don't think you shouldn't be forced to use something if your brain does not think that way and there's something that works better. So I'm going to start with the distributive property, and I'm going to show it in two different ways. So first here I have y squared times 4y squared plus 2y minus 3. So oops, I accidentally went to the next slide. So y squared is considered a monomial because we have one term. So that is one term right there because there's nothing added or subtracted to it, it's just by itself. The 4y squared plus 2y minus 3 is considered a trinomial because there are three terms. So if we have one thing times three things, we should get three things resulting because 1 times 3 is 3. So when you complete the multiplication, you should have three terms written down. If you don't, that tells you that you either multiplied too many times if you have more than 3, or not enough. You missed something if you have less than 3. So that's one way to keep track of what you're doing. So the distributive property we've already used. I used it with the -1. Now we're going to be using it with something that's not a number, but it's the same concept. So you are taking what's in front, the y squared, and you're multiplying it by what's inside, which is 4y squared. So usually I do this in my head, and you want to get to the point where you can do it in your head, but you guys are not there yet, so I'm going to write out all of this. So I am taking a y squared and I'm multiplying it by 4y squared. So I'm actually writing that out because they're not numbers anymore. And then I need to take that y squared and multiply it by the 2y. So I'm going to write that out. I'm having my y squared and I'm multiplying it by 2y. Then I take that same thing in front, that y squared again, and I'm multiplying it by a -3. So that minus in front of the 3, we're going to treat that as a negative. So I have to write these all in parentheses to indicate the multiplication, because otherwise if there's a negative it might get confusing and you might start thinking of subtraction, but this is multiplication. So when you're multiplying these, and then this is where we get into P.2, where you're simplifying exponential expressions. So you would be multiplying the numbers. Now for our first term here, we have y squared times 4y squared. We don't have anything to multiply 4 by, so 4 just sticks out in front. With the y's, when you multiply things, you multiply letters together, you add the exponents. So that's a y squared times a y squared. So we're literally adding those exponents together to get 2 plus 2. So I'm going to write that down. Usually I just do that addition in my head, but I want to make sure that you guys have that. Now the next term, I have 2, but I don't have any number to multiply it by, so the 2 just stays out in front. And then I have y squared times y. So if you have a plain y and there's no exponent, then we pretend the exponent is a 1. So that way when we multiply these and you add the exponents, we have the exponent on the y squared, which is 2, and then we're adding in another y.
Times y.
So that gives us 2 plus 1. Now, the last term here, I have a negative 3. There's no number to multiply it by. And there's nothing to multiply the y squared by. So those just get attached together. So that's a minus 3y squared. So now I need to simplify my exponents by actually doing the addition there. So I have 4, and then that's y to the 4th power, because 2 plus 2 is 4. Plus 2y to the 3rd power, since 2 plus 1 is 3. And then I could just write that as minus 3y squared. So now I have 3 things here, as I'm supposed to get 1 times 3 should give me 3 things out. And then you always look to see if there's any like terms. Everything here has a y, but none of the exponents match, so none of these can be combined. So we can't simplify any further. And that's our final answer here. Are there questions on that example?
You made that pretty clear.
Okay. So now let's move on to the example on the right. Now this one, I generally do not use the distributive property when I have something that looks like the thing on the right, but I'm going to show it anyway in case it works for you. So we have x minus 8, that has 2 terms, and then x plus 4, which is 2 terms. So 2 times 2 is 4, so we should get 4 things out when we're done multiplying. So when we're using the distributive property and we have something in parentheses in front, you work each thing separately. So first I multiply the x by the x plus 4. So I'm actually going to first write that out. X times x plus 4. Then we take what's next, this minus 8. So I have to write minus 8 there. And that also gets multiplied by x plus 4. So I'm splitting this up into 2 separate multiplication problems based off of what was in front. Then we need to distribute again. So now we need to multiply each set of parentheses here. So the first set, I have x times x plus 4. So that is going to be x times x plus x times 4.
Each set of
Then I have a minus 8 here. So that negative, that minus, we're going to keep that together. So that's going to be a negative 8 times x. So I'm going to write minus 8x. And then that minus 8 times 4. So that's minus 8 times 4. So you can see I now have 4 things written down. I've got 3 plus minus things in between, 3 operations, so I have 4 terms. Now I'm going to multiply these together. So x times x, that gives you an x squared, because if there's no exponent, you treat it as 1, and that would be x, and then you would add your exponents 1 plus 1, because both of them don't have an exponent. Then we have x times 4, and there's nothing to really multiply there, so those just become 4x. Then we have minus 8 times x, and again, there's not really anything you can do there, so that's minus 8x. And then we have minus 8 times 4. So 8 times 4 is 32, and we have a minus, so that's minus 32. So now I have x and 1 plus 1, so that's going to give me x squared, then plus 4x minus 8x minus 32. And you see that we have 4 terms there. But we need to simplify. We always simplify whenever possible. Always, always, always. And so you're looking for like terms. We have a 4x and a minus 8x. Those match. They both have x with no variable. I mean, no exponent. I'm sorry, I'm getting the, my brain is going ahead of me. So they're variables, no exponents. They don't have any numbers as an exponent. So those are like terms. So my x squared, I can't really do anything about. That's still x squared. But I can combine the 4x minus 8x, and you do 4 minus 8. So 4 minus 8 is negative 4. So that's negative 4, and then the x hangs out. And then I have a minus 32 that I can't really do anything with. And then that is your final answer. So while we multiplied, we had 4 things after we multiplied. You can simplify it down to 3 things. And you can see 3 is simpler than 4. There are fewer things. So that's why it's considered simplified. Okay, you're still wondering how we got 2 terms. What made it 2? So if you have we have an x and a minus 8. Those are 2 separate things. You can think of terms as being separated by plus and minuses. So I'm going to go to my highlighter. So I have an x and then an 8, and they're separated by a minus. So there are 2 things there. And whoops. And then on the second set of parentheses, I have an x and a 4. They're separated by a plus. That is also 2 terms. There is 1 operation between them. All right. Are there other questions? Okay. My next example, we're still multiplying. Now we're going to use the table method. So this is not shown in the textbook. I like this method, especially when I have a lot of things that I'm multiplying. So I'm going to start with our first example here on the left. I have 7x minus 2. So that is 2 terms because there's 1 operation in there. And then 4x minus 3, that is also 2 terms. So just like the last one we just did, we're going to get 4 terms when we're multiplying. So I'm going to set this up like when you had to do your multiplication tables. And so, oops. The first one I usually think of as setting up the columns. Really, you could do row times column, column. It doesn't matter how you set it up, just as long as you have something as a row, something as a column. But I usually take the first set of parentheses, and then I make that my columns. So I'm going to create a table. So I'm going to have 7x, and then I'm going to leave a gap so that I have room. And then I'm going to put the minus 2 together. And so that is going to be my columns. And then my rows are going to come from the 4x minus 3. So 4x is going to be 1 row, and then minus 3 is going to be the next row. And so now I've sort of created a table, and I have 4 blank spots. And so those are the 4 things I should get when I'm done multiplying. So I like this method because if you have an empty box, that means you're not done. So you can tell that you've multiplied everything together. The downside of this method is a lot of this needs to be done in your head, the multiplying. So if you're not so good with the multiplying and the exponent stuff, this might be a little harder for you. But you multiply your row times a column. So the first box, the top left, I'm taking my 4x and I'm multiplying it by the 7x. I'm basically multiplying those 2 parts together. So I do 4 times 7, which is 28. And then an x times an x. That will give me an x squared because I have 1 and 1, so now I have 2 x's. Then I move to the top My row is 4x, my column is -2, so I'm taking 4x times -2. So 4 times -2 is -8, and then I just have my x that hangs out because there's nothing to multiply it by. Once I fill those in, now I go to the next row. So now I have -3, and then the first column is 7x. So -3 times 7x. So -3 times 7 is -21. And then I don't have anything to multiply by x by, so that hangs out. And then my last box, my row is -3, my column is -2, so I have -3 times -2, which is a +6. So I have +6. The nice thing about this method is that when you have it set up, your diagonals are like terms. So you can see I have like terms in the -21x and the -8x. And so I can add those together pretty much straight away and get straight to my answer, and I don't have to write as many steps. So I start with my top left because that is the highest exponent. So that is 28x squared, and there's no other x squareds to add that to. Then I look at my diagonal. I have -21x plus -8x. So -21 minus 8, that's -29. So I have -29x. And then you're basically you're kind of working diagonals in a sort. All that's left is that +6, so I just write +6. And then I've already added all of my like terms and combined it, and that's your final answer. So that's how the table method works. A lot of it is done more mentally, but it's a little neater, and it's kind of lines up nicely. I'm going to look at the table method on the right here. This is where the table method is really nice. So on the right, we have 2x squared minus x plus 4. So that is 3 terms. And then we have x squared plus 3x plus 2, which is another 3 terms, which gives us 9 terms after we multiply. So we're going to have 9 things once we go through the multiplication. With that many items, it's really easy to make a mistake and to accidentally multiply the wrong things together or to forget something. The nice thing about a table method in this instance is that it's easy to see what you needed to multiply and if you're missing anything. So it's a lot easier to find your mistakes. So I'm going to set this up. I'm going to take the first one. That's going to be my rows. So I have, or my column. So I have 2x squared minus x and then 4. And then I'm going to go down, and I have x squared, 3x, and 2. And so now you can see that we've got 9 boxes there that we have to fill in. So I'm going to start with the first row, first column, x squared times 2x squared. So the 2 doesn't have anything to multiply it by, so that's 2. And then I have to add the exponents when I add these. So 2 plus 2 is 4. So I'm going to get 2x to the 4th power. Then I'm going to move to the right. I'm taking x squared and I'm multiplying it by -x. So that's basically a 1 times a -1. I'm going to get a negative. And then I can even write -1. And then x squared times x. So that x has an x1 and a 1 if there's nothing written there. And 2 plus 1 is 3. So that's going to give me x to the 3rd power. Now I take my x squared and then I multiply it by the last column, which is 4. There's nothing to really multiply there, so those just get attached together to get 4x squared. Now I'm going to move to the next row with my 3x. So 3x, and I'm going to take the first column, which is 2x squared. So 3x times 2x squared. So I'm going to do 3 times 2, which is 6. And then x times x squared. So you add those together. That x has an exponent of 1 if it's not there. 1 plus 2 is 3, so I'm going to get x to the third power. Now I move on to 3x and negative x. So that's 3 times a negative 1. I'm going to get a negative 3. And then an x times x is x squared. 1 plus 1 is 2 there. Then I have 3x times 4. So 3 times 4 is 12. And then the x just hangs out. Now I move to the last row. I have 2. So 2 times 2x squared. 2 times 2 is 4. So that's 4, and then the x squared hangs out. Then I have 2 times negative x. So 2 times a negative is negative 2, and then the x has nothing to multiply with. And then I have 2 times 4, which is 8. So now I've done all of the multiplication, and now I need to add my like terms. And that's where you look at your diagonals. So I have in one diagonal the x cubes, and if I change color, in another diagonal I have things that are x squared, and those are all lined up. And then in a third diagonal I have things with x's. So if you work with your diagonals, that's how you get your final answer. So I'm going to start with the top left, x to the fourth, that's the highest exponent. So that is 2x to the fourth, because there's nothing else to add it to. Next, in yellow, I have x cubed. I have 6x cubed minus 1x cubed. So those are like terms. I do 6 minus 1, which is 5. So that's plus 5x cubed. Now I have 4x squared minus 3x squared plus 4x squared. So those are all like terms. Those are all x squared. So I have 4 minus 3 plus 4. So 4 minus 3 is 1, and 1 plus 4 is 5. So that gives me 5x squared. Then in orange, I have like terms of the x's. That's minus 2x plus 12x. Minus 2 plus 12, that's the same as 12 minus 2, so that's 10. So that gives me plus 10x. And then I have 8 left over with nothing to add it to. And that is your simplified answer. I know it doesn't look simplified. It looks just as long as what we started with. But we did the operation. We multiplied those things together. And that is what we got after we combined everything. Are there any questions? Okay, couple things going in. That is a better way to do it, yes. Yeah, I mean, I think the table method is awesome, but not everybody likes it, so that's why I teach these other methods. But if you like it, go ahead. Got a few other people that are typing. A few other people like this way better. Yeah, I don't know why this is not taught in the textbook, because I think this is more intuitive. Got a few other people typing. Okay. So now I'm going to move on to FOIL. So FOIL is special because that can only be done in certain circumstances. So let's take a look at what FOIL means. So FOIL, F-O-I-L. Actually, let me move that. Let me write that, F-O-I-L, going down so I can write what that stands for. So F stands for first, O stands for outside, I stands for inside, and then L stands for last. So that's where FOIL comes from. It's just an acronym for first, outside, inside, last. This only works if you have a binomial times a binomial. It doesn't work any other way. And that means we have two terms times two more terms. So both of the examples here are binomials because I have two terms by two terms. So that's where I can use FOIL. It's basically just a method of keeping track of what you're multiplying. So for the first example, when it says first, that means you're multiplying the first term in each set of parentheses. So you're taking the 2x and you're multiplying it by the 2x. Then we move to O, the outside. So that means the outside terms. So that's the 2x times the minus 3. So those are on the outside when you look at what you have. Then I stands for inside. So the two that are on the inside, so that is 3 times 2x. And then last means the last term in each set of parentheses. That's 3 times negative 3. So this is what FOIL is. It's just a way to keep track of what you're multiplying. I think it makes a face, a little happy face. Because that's usually the way that we usually write our little arrows or whatever, it kind of makes a face when you're looking at it. So that's just a way to keep track of what you're multiplying. The table method works just fine here. But if you're going to use FOIL, that's the order that things get written in, and then you multiply. So we have 2x times 2x. 2 times 2 is 4, so that's 4. And then we have an x times x. So those exponents are 1 and 1. So I'm going to write that out. You're adding those exponents, 1 plus 1. Then we have 2x times negative 3. So 2 times negative 3, that's a negative 6. And then x, because I don't have anything to multiply the x by. Then 3 times negative 2, so 3 times 2, that's positive 6. And then I have nothing to multiply the x by. And then 3 times negative 3 is negative 9. So now I have my 4x, that's going to be 4x squared minus 6x plus 6x minus 9. And so now we need to add our like terms, and those are the 6's. We have minus 6x plus 6x. So minus 6 plus 6 is 0, and if that's 0, you don't need to write it at all. So we get 4x squared minus 9 as our answer. So we're not doing anything different here when we're multiplying. It's just another way of keeping track of what you're multiplying. So if I look at my second example, I have 2x times x if I'm going to follow the FOIL. So 2x, actually I want to make sure I have room for my arrows. So 2x times x. Then we do the outsides, 2x, oops, for some reason, come on, 2x to negative 4, so that's plus 2x times negative 4. Then we take the inside, 6 times x, so that's plus 6 times x. And then the last 6 times -4, so that's plus 6. And then in parentheses, -4. So now when we're going to multiply, so I have 2x times x. So I just want you guys to memorize that x times x is x squared. So that should be something, because you're going to be doing that so many times. So you want to get to the point where 2x's make an x squared. Then we have 2x times -4. So 2 times -4 is -8, and then the x hands out. Then 6 times x, there's nothing to actually multiply this, so those just attach. And then 6 times -4 is -24. So now you add your like terms, which are the x's. So we get 2x squared. Then minus 8 plus 6. So that's -2. So we get -2x. And then minus 24.
And I was wondering when you were going to be home, because Tyler said he was going to bring me cigarettes like an hour ago, and
So that gives us our final answer. We have 2x squared minus x minus 24. So are there questions on these FOIL process problems, or the two examples I've just done here? Okay, so far, let's see, Deanna is... Okay, Deanna, what is your question? If it's something that I've already answered, then I'll refer you back to when I have the recording, but if it's something I have not answered, then I will be happy to answer it. Okay, yeah, what's your question with showing work? 'Cause that's a really good question. Okay, so I showed 2x times x. Your brain knows it as 2x. Yes, you can skip that. So that step where I showed the 2x times x, the 2x times the -4, the 6 times x, the 6 times -4. If you can do that in your head, you can skip that step. That is, I'm writing that because there's a lot of people that are not at that point yet, but if you can do that in your head, you can skip that because it's clear enough where you're going when you go to the next step. But I don't recommend skipping the step where I have like the -8x and the 6x. I don't recommend necessarily skipping that because that's usually where errors occur, and so I do want to see that step, but you don't need to write the step before that. If you're ever unsure, it's always better to write more steps than you actually need. But it's great to ask because it depends on the type of situation on how many steps you need to do. Are there other questions? Okay, so I have a slide here with special products. I wanted to do examples of special products, but we've already been at this over an hour. And the special products are not so important because as long as you know how to write it, then you don't have to learn the rules. Special products, these are just shortcuts, and you do not need to memorize these. They're great, but if you're just learning, there's no reason to have to learn them. The only thing that you do want to do, or at least learn, is that these square root binomials, to know that if you see something like a plus b squared, that just means you're multiplying it by itself twice. So if you know how to write it and expand it, the table method, whichever works for you, and you don't have to use the shortcuts. So I did plan on doing an example of short, and I think because we've been at this a while, that I'm not going to go over that. I just want to make sure that you know that if you have something squared, that you write it twice, and then you can go through the multiplication process. And cube of a binomial there, I would not worry about that. It's in the textbook, which is why I put it there, but I don't have that memorized. So if I don't have it memorized, there's no reason why you guys need to memorize that, because it doesn't show up all that often. So I would not worry too much about those. Just go through the FOIL process or the table process, whatever works for you, and you'll be fine. So if I can get my computer to, oh, it doesn't want to move anymore. I think my PowerPoint sort of froze on me there. I was trying to get to my question slide. Do you guys have any other questions? There are several people typing. Okay, we got a nod at this time. Okay. This is for everybody basically. I don't expect you for all of this to sink in the first time you see it. That's not how math works. So what I recommend doing, it's going to probably take a while to process this video. Last time I had one this long, it took, it depends on how busy Blackboard is, but it actually took like 3 or 4 hours to process the video. So I can't guarantee I'll be able to post this recording immediately. But when it's processed and I post it, the nice thing about it being recorded is that you can review this and rewatch it as many times as you want. And if you're having questions when you're watching it again, you can then ask me questions. You can email me and say, okay, at this timestamp, can you explain what you did here? Or I don't understand how you did 2 times whatever. So that's the nice thing about the recording, is that you can review it again and have it sync through. One thing I have heard some people do is that they will watch the recording and then they will pause it before I do the problem, and they'll try it on their own to see how much they remember. And then they'll play it to see if they, if they remember the steps. And it kind of as a way to test out what sank in. So that's a good way to do it, is to rewatch it again, pause it, try the problems, and then you'll see my solutions and see if that matches. So that's what I would recommend doing. If this all makes sense to you, then you can go ahead and start watching the video that I have on P.4, which is factoring. And if factoring is difficult for you, and we're going to be factoring a lot during the class, then I would recommend maybe finding some extra videos on factoring. I have some on my MA104 playlist that go through into much more detail how to factor, because you're going to be factoring every single week. So that's something that's really important to get down if you can. So that's all I've got for you guys. I don't want to hold you too much longer. I really appreciate that you guys were all able to sit through this for an hour. I know it's like probably testing your brain. You're like, oh my goodness, I've been sitting here for an hour watching this. Take breaks, definitely don't go straight into the discussion from here or something like that. Take at least a half-hour break before you do any more math after this. That's what I suggest everybody does. But if you have signed up to Remind, I will make sure that I send the recording out through there and send a notification. And then if you have the Blackboard phone app, you'll get a notification from me as admin. So
That's it.
Sounds like we've got a very, very excited dog. So, my
Yeah.
dog, luckily, was very good on my lap.
They
she's,
saw
she's
someone pull
awake,
it.
but she's very.
They saw someone pull in the driveway, and they just don't shut up. I'm gonna turn my audio off.
All right. Well, I'm going to stop the recording, make sure this processes and everything. But thank you guys so much for joining. And of course, contact me anytime if you guys have questions. So I hope you guys enjoy the rest of your Sunday. Definitely make sure you take some time to yourself and spend time with your family and all that. So you guys have a great day.